Hey, it's Mr. Sim Guy here with the first video in my new series on the cardiovascular system. In this episode, we are going to break down the flow of electricity as it passes through the cardiac nodes and compare them to the tracing that we see on an EKG. Things to remember: we are only looking at the electrical pathway and not the mechanical function of the heart. Stay tuned for more new videos on that. We are looking at the normal pathways as we follow the signal down from the brain through the sinoatrial node, also known as the SA node or the sinus node. That electricity then travels down through the atrioventricular node or the AV node, and then through the ventricles, followed by repolarization and resetting of the system to get ready for the next signal. When the signal is sent from the brain, it arrives at the SA node. This node then depolarizes, sending electricity through the cells of both atria, hopefully causing a contraction of the muscles. When the SA node depolarizes, we see an upward inflection on the EKG referred to as the P wave. To keep this simple, the P wave means that we have a sinus rhythm, or at least that the underlying rhythm is a sinus rhythm. We'll talk more about that in my next session, all about the P wave. The electricity then travels to the AV node where it gathers and prepares to depolarize. This gathering is happening during the PR segment of the EKG. The AV node will not depolarize until it has enough electricity, so there should be a small pause while the EKG returns to the isoelectric line. Once the AV node depolarizes, the electricity is sent down through the bundle of His and then splits into the two bundle branches, the left and right, where it then spreads out through the Purkinje fibers. We see this on the EKG as a series of downward deflections and upward inflections called the QRS complex. If the electricity does not pass through and cause the AV node to depolarize, we cannot have a normal QRS complex. So we measure the width and the shape of the QRS complex to determine this and see if the electricity was generated above the AV node, in the AV node, or below it. The wider the QRS, the lower the starting point for the electricity, and more on that later. If we map the electricity leaving the AV node, it first passes through the bundle of His, which runs along the septal wall of the heart. We can see this happen on the EKG with the presence of the Q wave, so we can say the Q wave represents septal depolarization. After depolarizing the bundle of His, the electricity splits between the left and right bundle branches. These bundle branches supply the electricity to each respective ventricle. We can watch the electricity travel through the bundles on the EKG as it creates the R wave. The peak of the R wave is a crucial reference point as we will use it to determine the rate and regularity of the EKG. It also tells us how much electricity is needed and so many other things that we will get into in other videos. Once the electricity passes the peak and starts the downward path, we're looking at depolarization of the Purkinje fibers. This is the S wave, and it will be a negative deflection on a normal EKG. This culminates at the end of the depolarization cycle. Once the Purkinje fibers are depolarized, electricity stops, and we can see the EKG tracing return to the isoelectric line while we wait for the cells to repolarize. We will then see this ventricular repolarization with the presence of an upward inflection called the T wave. Once the ventricles are repolarized, the EKG will return to the isoelectric line while the SA node waits for the next signal to come from the brain. Okay, so what we just saw was one electrical signal travel from the depolarization of the SA node all the way to the end of the Purkinje fibers and then the repolarization of the cells in the ventricles. We need to understand the normal pathway before we can start to understand the many ways that the system can fail and the backups that the system has built into place. For that, look to my upcoming videos in this series, and if you like this video, please hit like and subscribe below, and we will see you at the next episode of EKG Interpretation, where it is all about the P wave.